Good afternoon, everyone. Welcome to Data Tech Talk for LinkedIn's TechCon 2022, powered by Women in Tech. Thanks to each one of you for taking time out to be a part of it. I hope you're having a good time exploring the different networking booths and talks at the conference. I am Anirban at LinkedIn. I'm a part of the productive machine learning team from the engineering side. I help improve the machine learning lifecycle of ML models at LinkedIn at scale. We'll talk more about it in one of our following sessions. Next slide, please. A quick note to the audience, please feel free to drop your questions in the Q&A tab of your chat box on the right. We'll be answering all of our questions towards the end of the session. Next slide, please. For the opening talk, we now have Uma, who will be taking us through an overview and different data teams that we have at LinkedIn. Over to you, Uma.
Thanks, Anirban. Hey, everyone. A very warm welcome to today's data session of TechCon 2022. I'm Uma Sawant, and I manage the consumer and enterprise teams at India AI. I often get questions about the role of data and AI teams at LinkedIn. What problems do we solve from here? What kind of platforms and technologies we use? And what kind of research opportunities exist? I'm glad to take this opportunity to provide you an overview of the LinkedIn data team. You're welcome to network with any of us, any of today's speakers, to know more later on. Next slide, please. We say that AI is oxygen at LinkedIn. To motivate why, I have to tell you a bit about the problems we solve and the scale we operate at. Imagine a member, Naira, who is looking to achieve more in her to follow tech influencers and gathers updates from her network. She uses job search and recommendations page to explore new job opportunities. For continuous upskilling, she studies deep neural network courses and videos from LinkedIn Learning. She also uses My Network tab to connect with people at work or maybe at conferences and joins groups like machine learning for better focused conversations. Next slide, please. Now consider that, like Naira, we have 810 million users across 200 countries. If we were to visualize the LinkedIn knowledge graph, connecting such members, their jobs, their companies, skills, schools, and so on, the nodes themselves are more than 1 billion, and edges are many more. So like Naira's network expansion, the people that she's connected with, all of these billions of members are now coming closer to each other, forming new connections, leading to 30% year-on-year growth in the conversations. We need to ensure that we have the technology to serve Naira's and other millions of members at scale. The data stream forms the core of this technology. Next slide, please. The critical component in LinkedIn's technology ecosystem are our AI models that focus on building a safe, trusted, and professional community by limiting the hateful, violent, irrelevant, and misinformed content. These models ensure that the relevance of our feed, jobs, groups, learning, and all other products remains at LinkedIn. And while we think about the models or the algorithms, let's also not forget the platforms that enable building and serving these models scalably. The data team is about addressing all these challenges together. Next slide, please. So far, I have talked about LinkedIn's data needs and how the data team serves it. The engineers addressing the above challenges are spread across multiple teams in different time zones across the world. Now, let me tell you a bit about the specific charters driven by our India data team and how they have evolved over time. Our data team in Bangalore started in late 2015 with focus on keeping LinkedIn's platform safe from unprofessional content. Over time, that charter has expanded into content moderation AI, which employs different technologies such as classification, near duplicate detection, and virality prediction for identifying and limiting bad content. We also expanded on other consumer and enterprise side problems. Let me give you a few examples. For LinkedIn's learning platform, we work on understanding the user intent and accordingly produce diverse results such as courses, videos, books, and learning paths. Other notable problem we solve is serving the needs of our blue collar member base. For example, retail store workers, cooks, and cashier. We work to ensure that this member base is correctly represented in our models, making their LinkedIn experience better. Recently, we have also started working on LinkedIn groups, making the discovery of relevant content, increasing member conversations, and aiding sustained growth of LinkedIn groups. We spoke briefly about platforms earlier. In 2017, LinkedIn recognized the need to scale efficiently and began a program at LinkedIn called Productive Machine Learning or ProM. We also have a team here, and Anirban spoke about it earlier, which invests in building and improving the AI platforms for multiplying our productivity. So starting from one engineer in 2015, today the data team has more than 80 researchers and ML engineers developing the state-of-the-art natural language processing, computer vision, multimodal, and graph machine learning algorithms, and also the productive ML platforms, which aid in building and serving these algorithms. We also patent and publish our work at Tier 1 conferences. So that was a brief introduction to the data team at LinkedIn India. In the next 30 minutes, you will hear more details about all these problems and the platforms that powers the solutions. I will now hand it over to Anirban for the next part of the talk. Thank you.
Thanks, Uma, for the great insights. Next up, we have Jyotsna, Nikita, and Mipsa, who will give a brief overview of the various verticals the Bangalore AI team works on, such as establishing member trust, building consumer and enterprise products like search capabilities on LinkedIn Learning, ranking in groups, etc. As a reminder to the audience, feel free to drop in your questions in the Q&A tab and your thoughts in the chat box. Over to you, folks, Jyotsna, Nikita, and Mipsa.
Okay. Thank you, Anirban. Next slide, please. Before this, Uma enlightened us on the scale we operate at. Do you wonder how our 810 million users have such a safe experience at our platform? Hi, I'm Jyotsna, an AI engineer building solutions for the Trust AI team at LinkedIn Bangalore. Next slide, please. Next slide. Referring to an earlier example of Naira that Uma gave, Naira trusts LinkedIn to be a safe and professional platform for conversations and content sharing. We at Trust AI team drive towards protecting that trust of our members by moderating the content that violates LinkedIn content policies and is unproductive for the platform. Next slide. The amount of harmful and unconstructive content shared over the platform varies with time. Specifically, during these global events, there is a call to attend to such spikes that could potentially disrupt our members' trust. Be it misinformation circulated during the onset of COVID, fake news and unsolicited political content during US elections, hate speech propagation during BLM movement, or inappropriate content sharing during Israel-Palestine conflict and Russia-Ukraine conflict, our defenses have immensely helped prevent propagation of such content to our members. Next slide. Coming back to our member Naira, her engagement with LinkedIn platform occurs at following 7 avenues, trusting it to happen in a safe and secure fashion. From preventing account takeover at registration and login portal, preventing fake account connection requests to Naira, handling any harassment or scam emails she might get at messaging, securing payments against fraud and chargeback at gateways, giving Naira all her privacy controls, fending off any bad content and fraud ads at LinkedIn feed, to preventing application on fraud jobs, Trust has a key role to play everywhere. Our team, Trust AI at LinkedIn Bangalore, primarily focuses on moderating content for the LinkedIn feed. Next slide. LinkedIn's public content trust policy deems certain content inappropriate for creation and sharing on the platform. Depending on the type of abuse, policy mentions various content categories. As we can see here, illegally regulated commercial, hate speech, misinformation, adult content, graphic, and violent. These are some of the content categories, and this list is not exhaustive. With 10 plus existing services to create content, combined with 10 plus content policies in place, we have more than 200 problem areas to apply AI solutions to, and each with its unique set of challenges. Next slide. Our mission to maintain NIDA's trust on us is fulfilled by building proactive defenses, and there are 3 pillars to those defenses. Next. The first pillar, the classifiers, are AI models built over state-of-the-art ML algorithms, making use of deep neural networks, transfer learning-based solutions for computer vision and NLP problems, recommendation, ranking algorithms, etc. These classify each content into policy violating, unconstructive, or clean. Second pillar, the near-do detection frameworks identify exact or near matches to any bad content that is already known to us. Third, if some bad content is likely to go viral, virality prediction can help us identify that. Next. Now, these defenses can work at such a scale seamlessly as we are supported by our very strong foundations. As part of AI productivity, we have a streamlined framework to quickly build and launch AI models while adapting to any change in data distribution over feed. We also build our in-house solutions to foundational problems like object detection and OCR. Along with that, data-driven measurements and insights enable extensive experimentations and are directed through key metrics. Finally, fairness. Fairness ensures that content moderation predictions are checked for presence of any biases, and these biases are eventually mitigated. With over 50 plus AI engineers, Trust AI helps establish LinkedIn members' trust with its solid defense system built over robust AI ML technologies. Moving on, let's hear from Mipsa on Groups AI and Learning Search.
Thank you, Jyotsna, for giving an overview of the work that we do to maintain member trust. Hi, everyone. I'm Mipsa Patel, and I'm a part of the Groups AI team here at LinkedIn. We will now discuss some consumer and AI enterprise specific initiatives that we have here at LinkedIn. Next slide, please. We heard about the example of Naira, who wants to achieve more in her career as an AI engineer. She wants to learn new skills, take part in relevant conversations, and build her brand. To do this, we discussed 2 initiatives that help her achieve these goals. The first one is Groups, which enable her to interact with members outside her network and connect over common interests. And the second one is LinkedIn Learning, which enables her to upskill and learn the required skills. Next slide, please. Let us first dive into the exciting problems that we are solving in the LinkedIn group space. So the groups ecosystem comprises of 3 groups of people: creators who create new content in the group, consumers who view and engage with this content, and admins or organizers that moderate the group. Imagine that our user Naira creates a post related to machine learning. While she would be able to get traction on the main feed, posting in a machine learning group would lead to a more focused conversation. For this purpose, we nudge members creating posts on home feed to also post into groups by recommending relevant groups that their content would be ideal for. Now, with this initiative, there is an increase in the number of posts. So we also need to ensure that Naira finds the most relevant, recent, and focused conversations in her machine learning group to consume. We do this by notifying and showing her the most relevant content in both the home and groups feed. Finally, We also apply the trust classifiers that Jyotsna talked about in the group's ecosystem to ensure that no bad or irrelevant content is present in the group. This also ensures that organizers are able to maintain the group as a safe space for the members. Next slide, please. Next, let's talk about LinkedIn Learning and the work that the team here does to improve the search in this product. Going back to the example of Naira, let's say she has a new work assignment on TensorFlow framework and she hasn't used it before. She comes to LinkedIn Learning and looks for TensorFlow related content. To deliver the most relevant content to Naira, the underlying search engine that we've built uses member, content, and query understanding techniques, retrieves the most promising candidate set across diverse content such as learning paths, courses, videos, etc., and finally ranks the most relevant content. Our initiatives are spread across 3 levels. First being infrastructure. The size of our search index that stores all the learning content has grown exponentially in the past few years. We are now resharding our index to scale up and also setting up a replay cluster to replay prod requests and spot check new models that we create. Next is the retrieval level. So when Naira searches for TensorFlow courses, the list of available content can be very long. Ranking all this content can be time consuming as well as less efficient. We are building better models to assign a score to documents independent of the query. This improves the quality of the candidate set that is consumed by the ranking level and also helps in maintaining the diversity of the candidate set. We also have some query understanding initiatives like named entity recognition and query autocomplete to simplify the search experience for learners and also guide them in the right direction to discover new content easily. The final layer is ranking, where we use wide and deep neural networks using the TensorFlow ranking library to build our ranking models. We generate learner embeddings using a model which consumes learner activity throughout LinkedIn site and also other static member profile features. I now hand it over to Nikita to talk about the research that happens within the team.
Thanks, Mipsa. Hi, everyone. I am Nikita, and I am a part of the Trust AI team here in Bangalore. So next slide, please. So as a part of the LinkedIn AI team, while we are actively leveraging state-of-the-art solutions and taking them to production, we are also heavily invested in cutting-edge research and coming up with novel solutions for multidisciplinary problems. And to be able to give back to the research community, we regularly publish our work in some of the top conferences in the domain. And also to help safeguard our novel solutions, we actively file patents as well. So the list that you see on the screen, that includes some of the recent work that we have published or filed in recent times. The patents which were granted, earlier filed and now have been granted, those include generating multimodal image representation for image, context-aware personalized query auto-completion, graph-based labeling of heterogeneous digital content items, content agnostic quality estimation and topic modeling, detection of neo-duplicate images in profiles for detection of fake profile accounts, which Mipsa also talked about, which Jyotsna also talked about earlier. Some of the patents that we filed in recent times, techniques for identifying quotations in images posted to a feed, utilizing image, visual, and textual content for recommendation systems, system and methods for poll intention detection and automatic poll creation. So these are the patents that were filed or granted. Now coming on to the publications. One of the publications that we recently published in CIKM was Understanding Job Seeker Funnel for Search and Discovery Personalization. In KDD workshop, Fairness for Text Classification Tasks with Identity Information Data Augmentation Methods. And in VLDB on LANS, a web scale approximate nearest neighbor lookup system, which was also accepted. So, and also we are also actively working on sharing our knowledge on wider platforms, not necessarily publications or patents, for open source use. So white papers is something that we also publish. So how data loop enables high quality annotation at LinkedIn. Next slide, please. So to make sure that knowledge sharing and learning is not restricted just to within the company, we time and again invite distinguished folks from the research community to present their work and interact with the team at large as well. So some of the talks that we recently had included talks from Professor Pushpak Bhattacharya from IIT Bombay, from Professor Vasudev Verma from IIIT Hyderabad, from Professor Abhijan Chakraborty from IIT Delhi, from Dr. Sunipa Dev from UCLA. And we are also actively collaborating with some of the best research labs in the country for problems which are relevant to us as well. And one of the ongoing collaborations that's happening is with Professor Tanmay Chakraborty and his lab at IIIT Delhi, where we are working with him on misinformation and fake news detection. So now I would like to hand it back over to Anirban to take it forward. Thank you.
Thank you for the amazing overview of AI at LinkedIn India. It's great to see the questions coming in from folks in the chat tab. I'll encourage you all to keep your questions coming, and we'll have it answered towards the end of the session. For the next talk, we have Ameya from the ProML team in Bangalore. Productive machine learning, or ProML, is an initiative to increase the productivity of developing ML and AI solutions at LinkedIn in a sustainable way. It provides an end-to-end unified and opinionated platform for building ML systems at LinkedIn. Ameya will take us through the different initiatives that we have as part of ProML. Over to you, Ameya.
Thank you, Anirban. Thanks for the introduction. Hi, everyone. Good evening. My name is Ameya. I work on machine learning infrastructure at LinkedIn. We call it ProML, which is, I think, as the slide says, it's productive machine learning. Our objective is to put out an opinionated set of platforms that our machine learning engineers can use in order to do their work well. Machine learning is something that we use at LinkedIn to solve a number of problems. Some of these have been highlighted by the prior speakers. And these are a very diverse set of problems, but also problems which are very special to the kind of domain that we operate in. I think with the work that we do in machine learning infrastructure, we aim to make it easier to solve a variety of these problems, but do them in a manner that is fairly scalable across different kinds of models and solutions. Could you move to the next slide, please? I again wanted to reiterate with respect to the numbers that we are talking about. Uma had a similar slide a while back. At LinkedIn, we are dealing with a total of 810 million members and growing. This number was a lot smaller, say a couple of years ago, and it has been continuously growing for a while now. This also includes members that are across a number of companies, and we have about 58 million registered company pages that we have at LinkedIn. And LinkedIn being a professional network itself, I think there's a lot of value that does come out with respect to how these different entities are related to each other. You are connected to someone else, you work at a given company where someone else does, and well, so you can get connected to a friend who's working in a different company, or people who have the same set of skills at you. And when we talk of scale, the 240 billion number, this really talks about the number of edges that we've got between these different entities that define our economic graph. The thing to call out is that the amount of data that we deal with is at a very big scale. And there are special problems that arise because of the scale that we are talking about. Could you move to the next slide, please? So I think a few more numbers over here, and I do want to emphasize and call out with respect to why these are important when it comes to machine learning infra. We are talking about a huge volume of data, 2 exabytes, 2 to the power of 15 bytes. It's a big number. There's like so many zeros in there, and that's the volume of data that we really have in storage as we speak, right? And with respect to communications and message parsing that happens between this data volume, we're talking about 17 trillion messages processed per day. But the thing that I do want to call everyone's attention to is not the really big numbers, but it's the small numbers of 200 plus experiments and 300 plus models, right? So we are talking about crazy scale, a reasonably high number of models and trillions of inferences. But the key is actually these numbers, which actually come down to the 200 plus experiments and 300 plus models, right? Why that is the key is because typically it's a lot easier to build a reliable platform that is able to solve a static kind of a problem and solve that well, right? The real complexity that does come in when it comes to machine learning infra itself is when you're dealing with models which are fundamentally different from each other, right? None of these inferences are the same. The kind of infrastructure that you need to run a recommendation model or a ranking model that is quite prevalent in a use case that LinkedIn has is going to be very different from what you're going to need for classification. You will have different nuances. For example, there are things that you might need an immediate response to. There are models that you might be okay if it takes like a few minutes to process. And that scale really brings in the complexity, and I'd argue even more so than the sheer volume of data that we deal with. Could you move on to the next slide, please? So I'm going to walk the group through a typical AI modeling lifecycle that anyone goes through. And these are all problems that we seek to solve as a part of the ML infra team at LinkedIn. So with respect to any AI engineer, typically one is always going to begin with some amount of a problem definition and requirement gathering. You want to solve a problem. You want to define a problem to begin. So for example, one might say that, hey, I want to make sure that memes are not going to be distributed very much, or I want to make sure that adult content is something that we definitely do not show on LinkedIn, right? So this is what you would call like a problem. You would identify objective metrics. So then you say stuff like, okay, I want to make sure that less than 0.001% of all adult content can ever pass through all of my filters. But ideally, it should be closer to zero, even more, right? You want to define what are the serving requirements. You want to say that, okay, do I want to serve this with responses that I need within a few milliseconds worth of time? Is this a model that deals with a huge amount of data and embeddings for which I'm going to need very high memory bandwidth? There could be different nuances that come with it. But what is important to begin with, even before we start with the process of really the modeling, is we want to clearly understand what are we looking to solve, and how are we going to identify whether we've solved that problem well or not. And when we do solve the problem, what are the requirements that come to serving? Could you go to the next one, please? So once we've defined the problem, I think fundamentally when it comes to AI, one would typically go through a phase that goes through data collection, data preparation. So you have data that has been ETL'd, and you're going to use that in a bit of a feedback loop in order to train your model and go forward, right? So initially, to begin with, there is some amount of data and feature exploration. You want to understand how do I derive features from the raw data that one does have. One's going to label a subset of this data to establish the ground truth, modify features, transform features, filter out features in order to have a data set that you want to work with. And yeah, the eventual feature engineering to take it to a place that your model and your training pipelines can fundamentally understand. Could you go to the next one, please? Next one typically goes towards training. So we've got all the data that we've got to do the model. We've got some label data from which we can get some ground truth. Now what we want to do is we actually want to use this data to train the model, evaluate the model that it is good. So I think to begin with, we start to experiment with different kinds of approaches, different architectures, different kinds of models in order to solve our problem. We train the model, we go into a feedback loop, we look whether what we are doing is something that's working, something that's not expected to work. Do we need to change the model architecture? And we get to a reasonable kind of a solution saying that, okay, I think this is something that can work for me. And, I want to move ahead and actually check against a larger volume of data. So at this point, what you do is you have some ground truth that comes in from your label data. You've got a testing data set too, potentially. So you're going to evaluate the model against that. figure out whether, hey, what I've done is good. Are there things that I need to tune? Is there any amount of hyperparameter tuning that one needs to do? Eventually, you need to go through a phase around rewriting. Typically, rewriting is the phase that you want to use in order to make sure that the model that you have is something that is production ready. So this would involve techniques around model optimization. You may want to perform some amount of distillation over there. You may have a number of compression techniques that you can use in order to make sure that the model itself becomes a little smaller, or the serving footprint, the hardware footprint that you're going to need for your model is not as big or as expensive as you move forward. Once we have reasonable amount of confidence that the rewritten model is in a good place, we go on and we publish the model artifact and really make it available for the actual serving. Could you go to the next slide, please? The last part is really around the deployment and monitoring. So this deals with productionization and post-productionization steps when it comes to AI models. So I think to begin with, even before deploying the model, we want to make sure that, we want to validate that the model indeed is deployable. For example, you could have a simple question saying that, hey, do I have enough RAM to serve this model in the kind of boxes that I do have? Or do I have all the access control to all the underlying data that I need to access in order to actually perform inference on this models, right? So there are a bunch of these basic checks, and this section really becomes critical, because if we don't do this right, we are going to run into site up issues, and this will have a direct business impact. When it comes to, well, you're literally bleeding money if you don't do this right. You move on to the next step, which is to really go and deploy that model and start to serve inferences. So this deals with areas of artifact management, and you want to make sure that the model that you have, you're able to evaluate that to solve whatever business problem that you need, right? Obviously, I think once you're in a place where you're able to serve your model, the next thing that one needs to do is to obviously experiment. So LinkedIn is a very data driven company, and we want to make sure that we actually try the model out against real users, perform a set of testing. So it could be A/B testing for a number of situations in which we are trying out fundamentally different models. We could have A/A testing if required for certain use cases, and gradually ramp it, measure metrics from it, go through the entire life cycle out there, right? But it doesn't really stop right after your A/B test, right? Let's assume that we've figured out that, hey, this is a model that's working well for people in this specific age cohort. Say I have a model that's working really well for people who are looking for entry-level jobs. But things can change eventually, because ultimately your AI models are only as good as the data that you've trained them on. They are garbage in, garbage out in some sense, right? You give it data that you've trained with, it's going to perform well. You try to infer an outlier, you're probably not going to get an expected result, right? And fundamentally, the pattern of data that one deals with can change, and this change can happen over different intervals of time. For example, over time, over a year, there could be a difference with respect to a few topics that are trending. And if your model is not intelligent enough to identify that, then you're going to serve substandard results. On the other extreme, there is situations like virality, in which suddenly there is something that goes viral, and if your model is not able to deal with that, then you have a problem, because again, you're serving subpar content to your end users, right? And given these situations, it is absolutely important that even after my model has been fully ramped, we want to make sure that we want to have ongoing health evaluation, ongoing monitoring, even after the model has been completely ramped. So we want to measure what the model is doing, what kind of data the model is dealing with. Is there a fundamental change with respect to this data? Is there a change with respect to my serving characteristics? And if there is a problem, we want to flag that as easily as possible, fix this problem in whatever way. It could mean that we have to go and retrain this model and go through the entire data collection evaluation lifecycle again, and serve a new model. And each of these steps will result in a direct business impact, because if you are serving more and more relevant information, you are fundamentally generating more and more value for members at LinkedIn, right? Could you move on to the next slide, please? Right. So I think I do want to emphasize that the field of machine learning itself is a very fast moving field. Like the kind of solutions that I've seen at the company, say 2 years ago, is very different from the landscape that I see right now. And in fact, if you go back even a few more years back, like I joined the company in 2014, and at that point of time, we'd think of people who would deal in AI as, these magic wizards who would wave a magic wand and, come up with fancy results that just fixes the problem. It was a very esoteric field, and that is changing with time, and that's changing due to a number of reasons, right? Fundamentally, the way I'd want to break it down is number one, we are doing much better with education to begin with, right? When I went to college, there was like a single machine learning course. Right now, if I look at the syllabus that's really being taught, whether it's happening in colleges or whether it's happening through coursework, otherwise, you go to LinkedIn Learning, you go to Coursera, you see a ton of content through which one can learn with respect and one can understand what machine learning is all about, right? Number two, I think it comes with improvements in technology. It would have been impossible to train the kind of models that we are dealing with today, like even as early as 3-4 years back. And that frontier is something that we are reaching again and again, and we are coming up with better and better models, more different techniques. Even with things that do get towards open source, we are getting towards an explosion with respect to the number of ways in which we can solve the problems, number one, but also number two, with respect to the number of people who are able to solve these problems and provide value. But as the number of these solutions increases, it can get very easy to get into a trap in which we've got like a number of solutions, and we are not able to scale as a company. And at LinkedIn, we did observe that. We thought we hit an inflection point, and which is why we decided about 3-4 years ago that, hey, we need to make sure that we are able to standardize our ML techniques to a reasonable limit. Not standardize, not to make sure that we are going to constrict the possibilities that we've got, but at least the process and the different steps and the life cycle that we do have, that is standardized in such a way that the infrastructure that we can build solutions that are able to scale to a number of models, a number of teams, a number of techniques, and so on, right? So that has been the big objective with which we've been doing work with ProML. Could you go to the next slide, please? Over the next 2-3 slides, what I'm going to do is that I'm going to focus on a few areas where we do work on machine learning infra in the team in Bangalore. Through the life cycle itself, we talked about a number of steps, and the broader team does take care of building out software that helps with all of these areas. But I'm going to focus on a few specific areas where we do work out of the teams that we have in Bangalore, right? To begin with, I'm going to talk about model health assurance. Think of health assurance as CI/CD for machine learning, right? What we want to do is we want to help machine learning engineers measure and monitor their models, the different features that contribute to their models, and the eventual performance. And we want to measure this at different phases of the life cycle. We want to measure how things are changing across different training runs. We want to measure how things are looking with respect to the actual data that you're performing inference on. We want to figure out how the data that you use for training is different from what you're actually seeing in real life. And it's we also want to get to a point in which we want to be able to solve questions around understanding why something might be going wrong. Like, for example, it is very easy for me to figure out that, hey, people are not clicking on jobs as much, right? But to understand and to give the explanation to say that, hey, people are not clicking on jobs because the distribution of ages of people who are coming into LinkedIn has changed, right? So to get to that kind of root causing is what we want to get to. The next step with respect to really figuring out whether something is wrong is to make sure that we are able to alert the right folks, right? Alerting can be a very tricky field, but we want to, what we are trying to do here is trying to say that, hey, with a high degree of confidence, can I inform the right people who are concerned to say that, hey, the model performance or maybe the features that you are seeing on your model are changing. And that might be a trigger for the person to say that, hey, this might be a good idea to potentially retrain my model in order to get more relevant results, right? What this enables one to do is to say that, the amount of confidence that AI engineers have with respect to the models that they have and the pipelines that they have is at a good level. So if it means that we've got a lot of these things taken care of, and I have that confidence that, hey, if something is going to go wrong, I will know when something goes wrong and I'll be in a position where I can fix that. One can move a lot faster and let our ML engineers really focus on solving the problems that they really like to solve, which is, to really add value through different kinds of modeling techniques and move faster, experiment faster, and generally do better when it comes to their work. So this has been the broad goal that we've had when we've been building model health assurance. Could you move on, please? The next set of things that we manage out of the team in Bangalore is around the area of model productionization. So productionization, we actually, we say that, hey, you're done with your training. What all do you need to do to make these models production ready, right? So there are a set of things that you want to standardize around model compression and optimization to begin with, to make sure that the footprint of the model is smaller. Once you have the model artifact ready, you get into the situation of artifact management. So you've got standard artifact management problems around things like versioning, around things around maintaining the blobs and bytes themselves. You want to make sure that when you need to deploy these models are things that you can deploy across a number of environments. You want to make sure that these deployments are highly available. The deployment is atomic in nature. You also want to validate what is the impact that these models have on the underlying infrastructure which is serving these models, right? Like, it can be very easy for one to say that, hey, I want to replace model X with model Y because it has a little higher accuracy. But what if by using model Y, I get to a point in which my CPU usage is suddenly 20% more? And this can potentially lead to a site-up issue on my side. And again, all of this results in a direct business impact. So it is these are not decoupled entities, and we want to make it easier to validate the impact that the models really have on the underlying infrastructure that serves these models, right? The optimizations themselves, some optimizations happen right after I train, but there can be a number of runtime optimizations that we can do to make sure that we are able to serve the model better. For example, you could be dealing with a model that deals with a large number of embeddings, and we might be able to do that cost effectively by really distributing and sharding these embeddings across a number of nodes, right? That lets us scale a lot better horizontally. So this is just a flavor of the kind of problems that come across when we talk about productionization. Could you move to the next slide, please? Lastly, I want to talk about the area that we call model cloud internally. What model cloud means is that we are talking about a fully managed model serving solution at LinkedIn. So the idea is that once the AI engineers have trained their models and the model is ready, with a few clicks of buttons and a few inputs coming in here and there, we want to make sure that there is an endpoint that is available that different teams can call over HTTP, that you can simply speak to it and get the inference result and not care about anything else. AI engineers do not need to care about the fact whether the amount of RAM that I've allocated is sufficient or not, whether I have enough compute bandwidth available on my side, whether I'm doing things efficiently, whether my utilization is in good shape or not, whether issues that come in around compliance and data governance, and making sure that sensitive data doesn't really escape where it needs to, making sure that we are able to run the models on the right kind of hardware. There could be, for example, some models in which I could use GPU to increase my throughputs, or even going forward, we could potentially at some point of time use fancier chips. We could use custom ASICs. We could use like FPGAs to really make our serving a lot more efficient when it comes to certain kinds of use cases. And by solving this problem across LinkedIn, what we are aiming to do is we are aiming to really optimize the cost that it comes to run these operations. And the cost is not just in terms of hardware, but also the human cost that it comes around being able to manage and run these kind of big infrastructures at scale. We also want to make sure that by the process of doing this, we have very detailed machine learning metrics that are exposed outside that our users can use to really understand how the model is doing, understand what impact it has on cost, and a number of other things. But eventually, I think the aim is that we want to make it very easy for our ML engineers to really get to market. There's a model that's trained. It becomes simple enough to simply say that, hey, I have an endpoint I can talk to, and I can use that endpoint to just get the inference and, well, move on and solve more and more complex problems. That's it from me, and I'm going to hand it off to Anirban now. Thank you.
Thank you, Ameya. That was truly insightful. It was great to know about the different offerings that the ProML team in Bangalore works on and the different charters that we have picked up. This brings us to the Q&A session. But before that, at LinkedIn, we do value feedback. So we would encourage everyone to log in the scan in the QR code and fill in your feedback. Let us know about the things that you liked about the session, that you didn't like, and how we can improve more around this. For the next, we'd like to have and discuss on the Q&A. We've had a bunch of questions coming in from a lot of different folks. I'll hand it over to Shreya to take over the Q&A session and drive us through it. Over to you, Shreya.
Thanks, Anirban. Thank you everyone for joining us today. I'm sure you've had a great time. I can say this from the list of questions I had to curate and that have been pouring in. We'll try to address most of the technology, AI, ML platform questions here. If you have any questions regarding the open positions, interview processes at LinkedIn, I would request you to reach out to the recruitment or the networking booths on our TechCon homepage. Okay, let's get started. So the first question is, if someone wants to take data science or machine learning as a career, what should be the starting point? What are the bare minimum qualifications that you look for? Uma, would you like to take a stab at it?
Sure. Yeah. So if you want to make a career in data or AI, one easy qualification we could look for is your minimum degree, bachelor's degree. Having said that, any advanced degree like master's would be useful. But I know many smart people who have made a career in this field who do not have any advanced degree. So ultimately, what we would look for are two main pillars. One is what kind of data mining knowledge you have and what kind of coding skills you have to translate those algorithms into platforms. So if you could, there are many avenues to gather this knowledge. You could either get a degree, or you could, if you are self-driven, there are plenty of resources already available. So that would be my advice. Work on these two pillars, and yeah, that's the answer.
Thanks, Uma. Thank you so much. The next one is, can you please explain the difference between the various data science roles, like data engineer, data scientist, ML engineer, AI engineer?
Yeah, maybe I'll take a stab at it, and Ameya can add on a bit. So, if you think about the term, the scientist and engineer, what's the difference, right? A scientist is someone who will maybe research and come up with hypotheses to explain some phenomena, right? Or an engineer is someone who builds things. Right? So that's sort of the artificial or the boundary that we could apply it in terms of data. A data scientist who will again come up, will do some research. They will understand the business, the direction we could take business to. Like to give you some concrete examples, if we want to increase the participation by new users coming to LinkedIn, we should send them X% more notification. Right? So that's one of the hypotheses a data scientist could give. Now, an engineer may take that hypothesis and identify concretely what do we need to do to make this happen. So maybe we need to identify who are the new features through XYZ features. We need to build so-and-so model and implement it. Right? So that's the sort of difference between a scientist and an engineer. Now, for the purpose of this talk, we are using ML and AI as interchangeable. There is no much difference. Yeah, but I will now hand it over to Ameya to explain more.
Yeah, thanks, Uma. I think you described it quite well with respect to the nuances between the scientist and engineer side of things. But even I think within ML engineer, and if you're talking specifically, there's a little bit of nuance here that you can be an ML engineer who's able to really build out these ML models which are able to solve these problems. But when it comes to the infra, I don't know what to call it. You may call it an ML infra engineer, which is a different persona you can talk of. But this is essentially more around building out the systems which can be used by ML engineers in order to actually perform different parts of the steps. So this is essentially even if you have a background in things like distributed systems, when it comes to core online serving and serving at scale, data processing, big data. I think all these skills with a combination of an understanding or even an appetite for AI can actually make for a great fit when it comes to an ML infra kind of an engineer role. It is a new role. You asked anyone 2 years back, what's an ML infra engineer? People would tell you, I don't know what you're talking about. So I think it's a new field. It is an interdisciplinary field in some sense. So there's not so much of a bar to entry per se when it comes to specific skills or specific domains. But it's flexible enough, and one can have backgrounds on multiple areas and really do well in this domain.
Thanks, Soma. Thanks, Amir. Moving on, how does one keep track of the latest ML techniques? Do you prefer a traditional technique or the latest one? Given that both solve the problem. I can add a little bit more to this question as well. How frequently do we change our models when some new solution comes in the industry that might solve our problem better? Do we keep testing or keep looking for better solutions? And how cumbersome is it to evolve? Mipsa, would you like to take a stab at it?
Yeah, maybe I can answer the first part and then hand it over to Jyotsna for
Sure.
second half. So in terms of how we keep track of the latest ML techniques, within the team, we do some paper reading sessions and brown backs where we pick up the latest research papers that are being discussed, that are being published, and as a team go through them and also identify how we can use these techniques for the problems that we are solving within the team. And with respect to traditional versus latest techniques, definitely latest techniques do give some advantages over traditional techniques. But again, there's a trade-off that we need to make between the performance of that technique or model versus the amount of computation required or how resource heavy the solution is and so on. So we consider both of these and we make a trade-off to determine whether our infrastructure supports it, and if not, what the effort required to make it work is. Jyotsna, do you want to answer the second part?
Jyotsna, you're on mute, I think.
I'm sorry. For the second part, that says how frequently we change our models for any new solution that is coming to the industry. A part of it is already answered by Mipsa, that yes, new techniques, new solutions, they are always, in most of the situations, advantageous because they give a very good performance. However, we have to see what aspect of performance they are actually better at and whether or not they are going to solve our overall problem that we are looking into. We have a trade-off, as Mipsa said. We also have to look into various dimensions. Okay, this model might be good at accuracy, but how is the runtime? And maybe we are good at runtime, but is our infra supporting it or not? And let's say if all of these are actually taken care of, the end goal that we are looking for, maybe we want to detect certain content and we want to detect certain type of positives and negatives, and we are not seeing too much difference on it. But there is a lot involved when it comes to onloading this new solution. Then we might take a hold. We might really judge on situations. Okay, do we actually onboard to this new solution or not? So yes, we do change our models time on time based on what is going on. If something is absolutely obsolete, we do want to discard it and move on to the next solution. But yeah, we also weigh how good it is. And do we keep this in testing pipeline? Yeah, like we always have our metrics those are getting tracked on all avenues, be it model performance, how it is doing on infra, how overall our when it comes to our product management, how are they actually seeing the performance of our models overall. So yes, we do keep a track of all those. Thank you.
Thanks, Josna. I think it creates the right segue for our next couple of questions. What are the various matrices that we check our model on? Nikita, would you like to take a step?
Yeah, sure. So that depends on the problem at hand. And that's the first step that we do while evaluating, selecting the metrics that we would evaluate our model performance on. So for example, we work heavily on content classification here in Bangalore team on trust. And the most common metrics that we use are precision, recall, AOC, computation, and all of that. So that depends on the problem. And you would choose your metrics based on what you want to optimize on. And that's how we go about it.
Thanks, Nikita. The next one is around how are A/B testing frameworks designed to isolate impacts of the various ML experiments running simultaneously? Uma, would you like to
Yeah, so
started?
that's the goal of the framework, right? Yeah, it's an involved question. I believe I
Yeah.
can't do justice to it in 20 seconds. But there are specific blogs. Engineering has a very nice blog on XLNT platform driving. We can put a link. I'm not. I can talk to our TA team to make sure that the audience gets that link. But encouraging everyone to go through that one.
Great. So, Sharon, can we have some way of putting this link in the chat window or circulating it into the team? Great. We'll take care of.
Yeah, we'll take that offline, sir.
Sure. Thank you. The next one is, I think this is from someone who is would be joining us very soon. Would be very happy to welcome you on board. So the question is, as an ML engineer, how can I also learn about building scalable models? Uma, would you like to take a step?
Yeah, so scale is a part of what we do, right? So whenever we think of a problem, we always have scale in mind. That when let's say I spoke about Naira's examples, right? Let's say we are building better groups related solutions. When Naira joins a group, she should be able to get the relevant groups content on her feed on day one. Now, we always have the thought in mind that like Naira, there would be millions of other users. So that's the thought where our models and design have built in. And that's why Amaya's team, for example, they're making sure that our models are able to handle scale. So again, there would be better, more detailed answers available on LinkedIn engineering blog. There are specific sections on what kind of platforms we have. So encouraging everyone to take a look. And we also can have a more detailed chat about this in the networking booth that are open to on both of them. Back to you, Shreya.
Thanks, Uma. Amaya, the next one is for you. What are the tech stacks for model training and inferences that we use at LinkedIn?
Sure. So we use a combination of open source tech, but also some proprietary pieces that we do have. So let's just look at the problem. So you said training and inference, right? So on the training side of things itself, we've built out a set of standardized components that definitely can be used. But I'll highlight the at least open source pieces of tech stack that we do make use of. So typically our training pipelines we run on top of Spark. The machine learning frameworks that we've got good support for right now is TensorFlow is something that is quite predominant. Now around the feature engineering side of things, and this is both on offline and online side, from LinkedIn, we've recently open sourced the ProML component around our feature store, which we call Feather, FEATHR. That's something that you may want to look on our GitHub. Then when it comes to the actual serving itself, we largely support TensorFlow runtimes. Onyx is something that we are making a big bet towards. Feather is something that we use extensively when it comes to the feature engineering side of things. I think a bunch of, as you go lower down the stack, there's other pieces. Like we're looking at heavily at things like Kubernetes, which is going to let us scale our models well, both when it comes to the training side of things, but also serving. On training, with respect to open source contributions as well, we've made heavy contributions to Horrorward, which Uber has put out, but we are active contributors and big users of that piece. So yeah, I think that's a flavor of the kind of tech that we do use at LinkedIn.
Thanks, Amaya. I think we've got time only for the last question. How do you handle the interpretability or explainability aspect of the model?
Okay, I'll take a quick stab at it. So at LinkedIn, we take both fairness, the privacy, explainability, and interpretability of model. Together, we call this as responsible AI. We take all of this seriously. We have a team at LinkedIn which is working on all these aspects. To answer shortly, how do we handle the interpretability or explainability? We either try to take a complex model and identify an interpretable version of it, or through design, while building, we build an interpretable model. But again, because of lack of time, I would redirect you to the LinkedIn engineering blog. There is a nice series of blogs on responsible AI, and you would get more information on this. Back to you, Shreya.
Thank you, Uma. That was our last question. Over to you, Anirban.
Thank you for the great discussions. And with this, we come to an end for the session. I know a lot of you might have a lot of different questions. So I'll encourage you all to join the networking booths that we have for the different sections, and we'll be happy to take more questions and discuss on it. Again, reiterating, I think we would appreciate your feedback on the session and how you felt. There's also a special swag that you can sign up for as part of the survey. So if you can opt in for your swag, you'll be able to receive certain different swags from LinkedIn. So hopeful that you're excited for that. Thanks to all of the speakers who took out their time and had a lively session. And thanks to the audience for tuning in and listening to the different sessions that we have. As again, the networking booths info is given on the chat, and we hope to see you around. Have a great day and good evening. Goodbye.